Hi, everybody. My name is John Henkel. I'm here with my friend and coworker, Laurent and Masia, and we're going to show you some things on how you can simplify your AV over IP deployments. We're going to give you some training on AV over IP, and we're going to go through some really cool things today. So let's take a look at the agenda for today, and you get an idea of what we're going to do. So we're going to talk about general AV over IP concepts and give you an idea of what that is, what AV over IP is. We're going to make sure that you understand the differences in like 1G versus 10G and all kinds of good things. And we'll get really deep. Laurent will be going over all the configurations for us and everything and topologies of networks so that as an AV person, you understand all these things you need to know now about AV over IP. We're going to then talk about some ways you can get some more education to learn some more about AV over IP, not only just from NETGEAR, but we have our own resources, but also other resources around the net. And then we'll certainly review the NETGEAR offerings, our switch lineup. We have quite a robust line of switches for you, and we'll show you what those are and how those can benefit you. And we'll give you a list of resources where you can find out more about NETGEAR products, as well as get some training from our own NETGEAR Academy. So stick around for that. We'll give you all the links. For now, let's get started with a little overview about what AV over IP really is. And Laurent, you can tell from our case studies, it's everywhere, right? All these venues, all these applications.
That's right, John. Actually, there's virtually no exception whatsoever for AV over IP in replacement of all legacy techniques, because we went from, digital to AV over IP.
You can find it everywhere. And just to make things really simple for you, high-end, top level, if you will, simply AV over IP is starting to replace the matrix switcher. That's the best use case, I think, for this. So on these simple examples, you have some encoders and decoders, often called transmitters and receivers. So you have a matrix switcher and you buy those with a certain number of inputs and outputs. In this case, it's a real small one. I don't even know if they make a 4x4, but I guess they do. 4x4 matrix switcher with some inputs and outputs, and that's it. So if you want to add some other transmitters, some other sources or other receivers, perhaps, you're done. That's it. Right? That chassis is full up. So there's no other way to do that. And that's where AV over IP really comes into play here. So you have a matrix switch, and Laurent can talk about this. As you add different encoders, decoders, it's the same philosophy, right, Laurent?
Absolutely, because by nature, Ethernet is expandable, right? You need more ports, just add more switches, and that's about it. So here, Ethernet becomes the fabric, so the matrix switcher is gone. In the middle, you have network, Ethernet network, standard Ethernet off-the-shelf switches. And now the TX are called encoders, the RX are called decoders, and see, it's a beauty, because everything is packetized and IP now.
And you've got things like the video wall, which is 4 decoders and a couple of multi-viewers on there as well. If you want to add more encoders or decoders, no big deal. Just plug them right in. It can be that asynchronous. You can have more inputs than outputs. Much, much easier than a matrix switcher. And you don't have to throw out the entire switch. And we'll talk about some ways to add more switches as well. So when we talk about AV over IP, there's often been discussion about these two different camps of AV over IP, the 1G versus 10G. And these are some names you might be familiar with, certainly H.264, 265, but you may not know like Pure 3, which is what Extron uses, or some other N2PICs. But there's all kinds of stuff, Dante AV, AVB now. Those are what usually are talked about when we talk about AV over IP. Those are the types of signals, of protocols, if you will. They all require a network switch, unlike HDBaseT, where you can't use a network switch. So all AV over IP, because it's IP, you can use a network switch. And then, certainly, Laurent, from doing a lot of these configurations, they do require a little bit of bandwidth, some of these signals. So the good thing is, as you start adding those up, you get to 100 gigabits really quickly. And our switches can work with all of these, right? It's all just IP.
That's right. And that's why we at NETGEAR play in both camps, right? We don't have a preferred. That's your application. I mean, 1 gig, 10 gig. At the end of the day, that's all the same Ethernet packets that we need to aggregate. And as you'd say, John, if you have a lot of those 1 gig streams, 10 gig is, at the corner. Yeah.
So let's talk, step back and look at a large picture, the possibilities of AV over IP using our switch at the center of this. This is our cool, you'll see a little bit more about this later on, a 96X switch, very modular switch So here we have all kinds of digital signage players, video cameras. We have all those going to an encoder. There are 10G signals. There's 1G signals. You have controllers as well. All this stuff can be run over a single network because it's all IP. And you can get multi-viewers. You can get video walls. And Laurent, you've been around this stuff for a lot of years. This is really what is the cool part about AV over IP, right? This flexibility.
Absolutely. And maybe above all, then you really streamline your AV installation here, right? Because see, that's a beauty. Encoders, decoders, that's it. I mean, all the applications are software-based applications. So you don't need any other costly equipment to multi-view, to scale, to video wall. So on the other hand, John, you're not an SE, but I know you are progressing very fast. If something goes wrong at the center, now that the fabric is in the network, well, the network switch got to work, right? That's the lesson. You got to make sure that the switcher is good for AV over IP. Yeah.
So some general concepts you need to be familiar with. And these are pretty simple, I know, but want to make sure they're all covered and we all get a base level here. So we talk about bandwidth. It really is just the amount of data sent across the network. So as you have an encoder that is taking your video signal and transmitting or changing that over to IP signal from an HDMI signal, let's say, sending that across the network, how much is that packet? How much is that stream? And it goes up really quickly. So the network switch needs to handle all of those streams together on input and output. Okay, so we talk about switch selection, and you might want to think of latency. Is that the most important thing, or is it the type of codec or the quality of the signal? Those are two big things that are usually brought up as in choosing a switch that you might consider. So we're saying those aren't really the most important, right? What's most important is bandwidth, making sure you have enough on the switch itself for all the inputs, also between the switches. And then also the number two most important thing in switch selection is that it's ready for multicast and IGMP. And Laurent, you know about these different terms. Explain a little bit about these. We'll talk a little bit more coming up too. But.
Absolutely. So the bandwidth, it's really obvious, right? If you have 10 gig encoders and decoders, you got to have 10 gig available on your network switch to connect them. And multicast is the protocol that really makes it happen on a network for video over IP transmission. 100% of all these codecs and video over IP transports rely on IGMP multicasting. Now let me get back quickly to the latency. Why doesn't it matter? Because for you in the AV industry, latency is measured in milliseconds, right? But the switchers, good switchers, bad switchers, all Ethernet switches in the world, they measure that in microseconds. So that's totally irrelevant for AV over IP, because switches will never add any latency to your AV over IP. And for codecs, that's pretty much the same thing. All that to us is packetized into packets. There's no good packets or bad packets. They are simply packets that we forward as fast as possible.
That makes a lot of sense. So the switch is not going to be the factor in your latency issue at all. It's the codec. Speaking of codecs, there's a triangle, and this is used in a lot of examples. You only have three choices, really, right? High quality, low latency, and low bandwidth. And you got to pick two. You can never get all three. So if you want to get high quality and low latency, well, you got to give up bandwidth because you're going to have high bandwidth for that. However, if you changed around and let's say, I want low latency, but I want low bandwidth as well, then your quality's got to give. So that's always a trade-off with all these designs. And that's what our NETGEAR team does all the time at Laurent's direction to help figure out what is the proper switch, proper design for your network to give you what you need.
That's right, John. And let me say that anyway, the AV job itself, the project itself will tell, right? Do I want zero latency and perfect quality? Or can I sustain high latency and all that, right? So the AV job makes that decision. But after that, yes, of course, with NETGEAR, we will make sure that we can power your AV over IP install with the right platform, whatever the codec you will use, of course.
And so there's always some trade-offs with AV over IP. I mean, there's trade-offs in traditional HDMI cabling as well for distance and flexibility. So there's some trade-offs here as well. The one thing to keep in mind, as we've talked about already a little bit, is bandwidth. If you have a 1G network that's already in place, well, that's great. but you're not going to be able to get as much throughput on that as you would with a 10G network. I think a lot of newer buildings, of course, are 10G networks nowadays. And the cost for cabling has come down. Fiber's a lot cheaper than it used to be. So you probably want to upgrade the network to make sure it can accommodate your network structure. And Laurent, you can talk about some more of this too.
Oh yeah, it's very simple math, and really congrats, John, because now I know you have put together this plumbing thing yourself in a PowerPoint slide. That's amazing, but that's really much it. 99.9% of existing IP networks for IT applications, whatever the vertical is not ready for AV over IP, because it's simple math. You have 10 streams of 1 gig, it's going to be 10 gigabit already. And those IP networks, they will always have that little pipe in the middle somewhere in between two switches that will restrict your transmission, right? So no matter what, the 0.1% remaining networks are pure data centers, but who is going to put together AV in a data center, right? So the lesson here is that we absolutely need to consider a fresh installation to sustain good AV over IP and hook it up to an existing network for control, of course.
Well, and one of the things we've talked about in other webinars and with other customers is that the existing network, the way it's designed, is already oversubscribed. And this was new to me, coming from an AV background to IT world. So for an office network, let's say that's already existing, or campus, across an educational campus, it's already been oversubscribed because not every device will be requiring bandwidth at the same time. So it's a bit different than to be able to come into AV world now, where I need a stream, I need 10 gigabits guaranteed, and I have 10 more streams, so I need 100 gigabits all going together here. So you can talk a little bit about that maybe, and the difference of the IT network that's oversubscribed and the AV network that shouldn't be.
Absolutely. So by the book, IT admins, they don't need line rate networks, because you and I, John, we sleep all the time. And, it's burst. So when you send an email, you don't need to have a rapid transmission. The email can wait. But wait, the video cannot wait, right?
Nope.
It's not possible to queue up videos, too many bits, too many bytes at the end of the day. So it really means that AV installation require a AV capable IT network. And that's why, to us, 1G versus 10G doesn't make any sense. That's not how you should consider your installation at the beginning. That's more of your requirements in terms of latency quality. And then when you have made this decision, you know that whatever it is, 1G or 10G, you will need plentiful of 10G for the interconnect.
Perfect. And we talk about the amount of bandwidth for this stuff, and these video signals are quite impressive. When you want to go full up 4K 60, 8-bit quality chroma, and then the bandwidth required for that, and this doesn't even take into account the overhead, because HDMI has an extra overhead that you wouldn't need to transmit normally, but just the raw data is 12 gigabits. That's a hell of a lot of bandwidth going across your network.
And that's where now you can understand that when you want to squeeze 4K 60, 4x4x4, the last row, into a 1G pipe, you need a hell of a compression effort, right? So a lot of compute. So compression means some kind of delay because you don't have a super calculator to do it. You have an encoder, and it will take some time. So that's why you got to give up a little bit on latency when you want to compress that much, and maybe also some quality, effect, because 12 gig to 1 gig, it's a lot. And this is also where we can understand that when quality and latency are absolute requirements for live installations, for instance, that's a good example, then 10 gigabit is a much better decision because you will compress very lightly and remove unnecessary bits per se only. Yeah.
And I think it comes down to perception. And again, back to the user requirements, often you can't even tell the 444 versus 420. A lot of people couldn't tell that. So it depends on the application. For a conference room, you probably don't need 4K 6444 for just a PowerPoint presentation. However, if you're watching our webinar back, or this recording back, you want the highest quality and the highest bandwidth, of course. It depends on the application. So we talk about adding more switches, and you get 2 switches involved, and what happens, and we talk about bandwidth. Look at this example here where you have 4 encoders up the top there coming to only 2 decoders down below. So in between the switches, all you really need at base level is this 2 gigabits. Even though you have 4 encoders up above, only 2 streams are being sent down below, or being requested by the decoders down below. So all you really need at the base level is 2 gigabits. Of course, you're going to want to have more headroom than that, because you never know if someone else will do that. But you got to think ahead, and that's the key point here, I think, right? It's just to think ahead of how much you will need and map it out.
Absolutely. That's a good math. Thank you, John. And never be afraid to, plan for more, because with AV, you have a proliferation of new applications, and sooner or later, you will add more encoders and decoders in this network. That's for sure.
Well, I think integrators here are certainly used to customers expanding their requirements after things are already in plan or actually installed. So, oh no, I want one more projector. I want one more encoder. Yes, that's going to happen. So you know it's going to happen. Plan ahead. Okay, let's look at some examples. And Laurent, you can talk us through some of these examples.
Thank you. Yes. So this one is actually a larger 60 by 60 typical deployment with cameras and servers and projectors and video walls. So in that case, you can see that we have 20 transmitters upper left and 40 of them are upper right. And in that case, because we go to a central switch, call it a core switch or a spine switch, then you will need to plan for 20 times 1G, if that's 1G type of AV over IP. So very simple math, but here it's pretty fixed, right? So 20 gig, 40 gig, you have a 10 gig spine switch or line rate, and then you can display and send your streams to your receivers on other switches. So that's very simple. Some AV customers in the past didn't call it simple, because you still have a whole lot of configuration to do for multicasting, for trunking, for stacking. But that's why we have this webinar today and this training, because we want to deliver good news to you later on. So stay tuned.
Yeah, I know setting all this stuff up, connecting them is easy, but you have to log in and set all the different settings correct, just to make sure you get the proper bandwidth and the proper set up to move those signals around these switches, for sure. So let's talk a little bit of, again, basic concepts here. We've got the basic ideas of what AV over IP is and all that sort of stuff. But let's talk about multicast and the difference of the 3 here. So unicast is pretty straightforward. It's one-to-one. You ask for it, you get it. Telephone conversation. I call you up, you answer your phone, we talk. Broadcast is the guy walking down your block with a megaphone. It just sends out the signal and everybody can pick it up. You don't have a choice, actually, to not pick it up. And then multicast is more like the radio signal, where you can tune your radio to receive that signal, but you can have your neighbor who tunes it to something else. But if you request that signal, then you're going to get it.
Yes, John. And 100% of the AV over IP technologies out there, from video to audio, you name it, 100% is multicast. Because doing that with a broadcast transmission would be criminal. Of course, you see broadcast in some other applications like lighting, because it's very small streams at the end of the day for the fixtures, right? But for video and audio, you would literally kill the entire network if one audio stream or one video stream would have to be sent to everyone, and not even mentioning unicast. So multicast is a beauty. But yes, multicast can be complex. You might have had a lot of issues at the beginning for AV over IP. So stay tuned. We have good news again.
We're here to help. That's what I like to say. One of those ways to help is what we call NETGEAR's IGMP Plus. So we've taken IGMP at the core level and all those things it does, and added some things together and done some special sauce on our switches to make sure it works better. It's not the right English, but that's what it does. It works better. Laurent, please explain.
Thank you. And same here. Pardon my French, but IGMP Plus really is the IGMP protocol we should have had 20 years ago. at the beginning of TCP/IP with Ethernet networks. So look at this way. IGMP is always good and simple on a single switch because you have the querier and the IGMP snooping happening on the same switch. But as soon as you have several switches, here we have 3 switches, very simple star topology. The querier must be one switch. Usually that's the core switch. And guess what? With IGMP protocol, all switches send all their multicast to the querier. Dump, right? So that created a lot of flooding problems, and well, we understood it at NETGEAR. We suffered from it. Many of other switch vendors say, well, for sure, this is IGMP. Go layer 3, go PIM, go multicast routing. But you're adding a hell of additional complexity for the PIM, the rendezvous points, and all that. So instead, at NETGEAR, we made that decision to re-engineer, rewrite the IGMP protocol. We called it IGMP Plus, and now we don't flood the IGMP querier at all. We just stay local in every switch. And if you, John, are on the switch 2, you have your decoder, you want to subscribe to that video coming from the switch 1, only then this stream will traverse the network and get to you. So IGMP Plus is fixing the original limitation of IGMP, and we can scale up to hundreds of switches without flooding. So IGMP Plus is available on all the AV line switches at NETGEAR.
And this is out of the box. There's no configuration needed for this. When you get a NETGEAR switch, you turn it on, you get IGMP Plus just from the get-go, right?
That's absolutely right. And of course, if you have plenty full other VLANs, you may want to configure IGMP Plus, but we have good ways of doing it. You'll see that.
Yeah, we'll show that. So let's talk a little bit more about some other topologies and configurations and how it was done traditionally and why you might want to make some changes to something like we just saw, the spine and leaf. So I can relate this because I'm the new AV guy, so I had to create some of these diagrams and understand what the problems were. So here's an obvious problem. If you have a traditional topology that's often used for network switches and one of those switches goes down, then the signal can't get past it. So it's going to stop right there and you're done until you replace that switch. So you need to have a redundant switch, a second switch around that's wired in tandem, and that can create a lot more latency and some delays, not to mention cost for all that. So with the spine and leaf topology of connecting these switches, a request is made. Great, you get the signal there. If that switch happens to go away for some reason, goes offline, there are other paths for that signal to take, and it can still reach its destination. And that's one of the best things about spine and leaf. So it is built-in redundancy just by cabling, really, which of course means it's less costly and also still will give you then a low delay and low latency. So those are a couple of different ways. You can see the traditional way in the upper right, just a little bit different, but it really helps make it a little bit more better again in the field.
Yeah, thank you. Good job, John, for explaining this, because that's a complex and difficult topic. But two layers only, spine and leaf, and it works very fast and reliably.
The AV guy's getting it finally. A couple of years in here, I'm getting all those concepts. It's not that hard, people. See, even I can do it. So I'm going to let you talk about trunk and lag because these are pretty complicated subjects, and these are some things you brought to the NETGEAR line to really help some problems in the field. So please let us know.
Yeah, John, thank you. So we talked about IGMP already. So we said that multicasting was not easy originally with IGMP. So we solved the flooding, right? Now IGMP Plus is taking care of it. But remember, when you have this architecture, spine and leaf, or maybe just 3 switches connected, you got to, make sure that the interconnect, the links between switches, they carry all your AV profile VLANs, because you may want to have control, separate VLAN. You may want to have audio for Dante in a primary Dante VLAN, and you may want to have your video in a third VLAN, already 3 VLANs in your AV switches, and trunking the ports so that they carry those VLANs in tagged mode is cumbersome because it got to be configured. So Now, if you need more than one link, because it's not enough, you need 20, you need 40 gig, you need several links to achieve that bandwidth between two switches. In addition to the trunking for VLANs, you also need to configure stacking or link aggregation, lags. And well, for IT people, that's everyday's job. It's like simple, but it's an additional configuration steps, and you not need to do the same between the switches, because if you configure your lag differently on the left and on the right, you will have communication issues. So trunking and lagging between switches was cumbersome. Yes.
So we did something about that. You specifically did something about that.
Yep, because we said now let's get rid of it. Frankly, let's get rid of it. So we added some intelligence and automation to the M-series AV line switchers at NETGEAR. And now we say, well, look, they're good for AV over IP because not only they're good with multicasting and IGMP, but also they let you focus on your AV job and everything related to the interconnect between the switches, so the trunking for all those VLANs, and then for the link aggregation on the right, because you have more than one link, this is happening automatically, like IGMP Plus. So really, I mean it, automatically. So this is removing complexity, but this is also removing possible mistakes, I can tell you, because a lot of troubleshooting activities in the past we have done with you, we found out at the end that, this interconnect was not configured properly. So this is going away, and this is automatic. Some might ask, well, how fast does it happen? Well, it's like if you and I, John, we would shake our hands. Okay, so we shake our hands, we discovered that we are not enemies, we're friends, right? So the switches will first block those additional ports with spanning tree. It's going to happen for 1 second. And at the second, the switches will discover that they're friends. They will remove the spanning tree and configure dynamically the trunking and the link aggregation. So IGMP, trunking, and link aggregation are happening automatically. Again, John, now I believe you have more time to focus on your AV.
Nice. I'll need some more time for that for sure. So one point about this too, that you still need to go into each switch and configure the VLANs, right? You do that individually. And then when you connect the switches together, then it's automatically trunked or auto-lagged, right?
That's right, because you need to tell the switch 1 that you have a blue video profile and the orange Dante or audio profile, and you are going to replicate that somehow on the other switches. And NETGEAR cannot disclose, the roadmap for next year in 2022, but, I wouldn't be surprised if a lot of even better ideas would show up sometime.
Absolutely. I know that's going to happen. So let's move along here and look at some examples really of stacking between switches here. And here's a couple of 96X switches, and they have fiber ports or copper ports. And you can see here we're using some fiber links between them, or the digital attach cables, which are handy for that long distance. And here we can connect, 8 different switches up together. With that example, with 192 ports of 10 G access. I mean, these switches are way capable.
Yes, absolutely. So that's just one example. And, I think it's the good time for me to say that we are here, at NETGEAR with a team called the Pro AV Engineering Services team. That's the NETGEAR Design Center for AV. We are here to do that for you. Okay, so we just want to display some examples because those are very common, usual types of topologies. But the team at NETGEAR is committing to that. We will help you design your network the best, for your typical application. In that case, yes, that's a very high performance, highly redundant spine and leaf stacking. That's a good example.
Some other configuration examples, specifically pointing out the VLANs involved. So you set up a certain part of the switch for VLAN 10, let's say, for those Dante items, and you can set up VLAN 20 for some other SDVOE items, let's say, but you set those up accordingly. And then again, look at your uplinks to make sure you have enough uplink capability to then send that up to the core switch. In this case, our M4500 switch, which is a 100 gig switch, and make sure that everything is set up and ready to go. So that's just one other example of a configuration using VLANs. I think we have another one coming up too.
Yep. So we can be very creative with all these, VLANs. I mean, you need to understand VLAN as a private network within your AV network, so that you have a private broadcast domain, if you wish. So your multicast stays local, for instance. But you can still offer inter-VLAN communication for control using this time IP TCP, typical control. And yes, VLANs are very handy sometimes when you want to maybe not rely on the algorithm for the load balance or the hashing between the link aggregation ports. And instead, you want to just, send those VLANs independently on, independent uplinks. So again, it's an example. There's plenty of other types of topology. And, usually this is your requirements that will let us understand which ones, which topology, should be best for your application.
This is, of course, an extreme example. Most situations won't be this large, but we have done examples like this and with hundreds of endpoints, and it can be done for sure, but you want to make sure you get some help first. Speaking of help, here's some educational resources. First of all, our online training academy, netgear.academy. It's a little bit different URL, but that's a place to go. We've refreshed it recently, and you can get all kinds of good high level and kind of deep level networking AV over IP concepts. You can also get your SDVOE design certification now within our own academy. And don't discount that if you're not doing SDVOE work. There's a lot of really good general AV over IP training there. A lot of certified courses there on AVIX's website. There's all kinds of other white papers, webinars, and more that we offer. There's tons of Dante training. Audinate does that as well. So there really are a lot of resources these days to learn about all this stuff. And you can get AVIXA credits for some of these things too. So that's always good. And as Laurent has mentioned, we have an engineering design services team to help you with your network design. Actually, they'll help you with a switch too. So Laurent, talk about that service that we offer free for people in the business.
Absolutely. We, John, now understand that, AV doesn't need hardware and software much, right? What you need for your AV project is really much service and support. So that's what NETGEAR wants to bring to the table to show our commitment. That's very simple. We took the best of the best in the NETGEAR departments from pre-sales, sales engineering, technical support, level 3 engineers, and we have grouped them into one team called the ProAV Design Center, proavdesign at netgear.com, proavdesign at netgear.com. What we do is really simple. We welcome you for free, of course, and we can help you at every step of your AV over IP project. Better to start early at the design stage so that we can help you, doing those typical decisions, which type of Ethernet switch, which are going to be the interconnect links and all that. And of course, we want to offer free service to help you during the staging, the installation, the configuration, and any troubleshooting situation, if any. And the good thing is that, you will have one member, proud member of this ProAV engineering services team accompanying you on your project from the beginning to the end. So you don't have to talk to the rest of our large ProAV organization at NETGEAR, but believe me, our entire organization is behind that team.
Okay, so what does NETGEAR bring to the table? What do our switches do? So we have three basic lines of switches, the M4250, our newest line of switches, and then the M4300 and M4500 switches. And they all have some of the same capabilities. They have different unique capabilities as well. And we'll talk about some of those coming up. We offer a ton of different port choices, port counts, from the modular 96X switch down to that 4500 that does 100 gigs. We do also all kinds of PoE, PoE Plus, PoE Plus Plus all the pluses we do for PoE. So lots of options there for whatever unique installation you're doing. The 96X, Laurent, this is a pretty cool switch and very unique in even network switches, even IT switches. This is a unique switch.
Yes, absolutely, John. And that's no secret. A couple years ago, when Netgear came live to this market with that switch, this switch was primarily designed for AV over IP installs because you never know if you will need copper, PoE, fiber. This is very versatile. You can start with an empty switch and scale, one day after the other, adding 8 ports, port cards. So that's really easy. That's like a Lego switch. But, well, thank you for bringing up the 96X. Let me just add, when I look at the entire AV line portfolio that we have for you, for your AV over IP job, the common denominator is that they are called AV line. So the IGMP Plus, the auto trunk, the auto lag, all these features are meant to simplify and accelerate your deployments.
And we have the newest ones, our M4250 series that we brought in 2 different waves. So there's 11 models altogether, and these are awesome. They look different. They're slick looking. They look great in an AV rack. They look good behind a monitor or up on a truss somewhere, even if they're out in public view. But it's a really different, unique look. All the ports are in the back. With all the status lights in the front, and you still have status in the back, of course, as well. We give you different mounting options as well. And if you want to reverse mount it in the rack, so you want your cables in the front still, we give you those rack ears with the unit. That's pretty unique. You don't have to buy them extra. It's silly. So we give you the possibilities for all this. Laurent, this is one of your things here, one of your features for sure, the threaded mounting holes, because you saw some people who were doing stuff that was not quite acceptable on previous models.
Oh, yeah, because you think of an event or a show, you have a truss, and we've seen some of our customers drilling into the switches. Please don't drill into an Ethernet switch. That's a serious safety issue, not only for emissions, but maybe also for the electricity, So yes, we understood that sometimes you have to use some clamps or other VISA plates. So these AV line, the latest ones, the 4250, were designed in collaboration with a lot of AV partners, system integrators, even manufacturers. And yes, this big M10 on the front and the M5 on the bottom, they let you, just use a variety of industry standard VISA or clamps. And that's good because this way you don't have to mess up and drill too much on those switches.
Good safety point. And something else I know you're very proud of is bringing this to the table for the M4250 line, the no fan option.
Yeah, this is a very common requirement. Look at your studio, John. You don't want to be burdened by, the fans because you have a noise sensitive environment. So in that case, yes, the AV line switches, unlike the more enterprise class 4500s, these switchers have, a fan management system, very easy. And if you really do not want any noise, just shut them off.
Easy. And it's if the conditions exist for it, if it's cool enough and everything else, then they can turn the fans off. It is smart enough to know if the ambient temperature gets too high, it'll turn them back on, of course. So don't worry about that. We thought about it. So here's the stack of all 11 models, the front and back, a wide variety of them available. And this is just the 4250 line. We still have all the other 4300s.
Yes, we have 12. So you're right, we got you covered. But it really depends again on the application. PoE++, 90 watts per port, 802.3 BT for the large soundbars, or maybe, even tomorrow, large tower speakers. You need, special switchers with huge power supplies. This 2U switch can provide to you 2800 watts. That's huge. But reverse, sometimes you need a smaller platform with PoE Plus and less ports. And all the time, Netgear will provide you with that flexibility so that you can go with 1G uplinks, because for Dante or audio or lighting, you don't need much bandwidth out of the switches. But as soon as you have video installations, then you need plentiful of 10G uplinks. So that's why you have choice in this family.
And I think one of the coolest things we've seen on a network switch ever has been this new AV GUI. And this is something that really came as a result of listening to the Pro AV community. And this is, I know, near and dear to your heart as part of this M4250 line. Why don't you tell us a little bit about this new AV GUI, if you would?
Thank you, John. Yes, absolutely. So remember, we spoke about IGMP a lot already. So we said that you need snooping, querier, fast leave, and IGMP Plus is facilitating it between switches. But still, you need to configure a whole lot of things in an Ethernet switch when you want to have this red or pink video profile for some encoders, decoders, and this blue audio other type of profile with some other ports. And you need to tag the ports for VLANs. You need to configure bonjour. You need to configure PTP. You need to configure diff serve with QoS. There's a long list of things to do that are really well explained and documented for Audinate, network guidelines, or any other AV over IP vendor. But we understood that the IT style is good for IT people. So those switches, of course, have IT interfaces like the CLI, the command line that we all love, right, John? But also the IT GUI with all these functions and features explained. But we made that decision based on very popular demand to stop doing that only, because now those switches, they ship with this additional interface. We call it the EVUI. And this time we don't show all of that. We only show what matters to you, John, for your AV job. And mainly this is about fans, because you may know that you want to shut it down or make it quiet enough. And C, the next thing is to ask you the question, what is that you're going to do today, John, on that switch? Are you going to do AVB? Are you going to do Dante? NVX, AMX, SDVUI. So we have these pre-configured profiles that are right there available for you.
It's really simple. I know going through this, I've done a bunch of short videos on some of these you can find on our YouTube channel as well. And you really click on that profile, up comes this window to say, okay, what color would you like these ports? So when you look at the GUI, you can see, oh, the blue ports are Dante or whatever. So you can choose the color. You can put a VLAN ID in right there as well. And you can do some more configuration here if you need to, but that's the basic. You can name it, color it, assign it to a VLAN, and you're done. And what you get is on the right side of the screen, you can see the different profiles that have been configured, the different VLANs, what the ID number is, what the name is, and you can tell at a glance which ports are optimized for that particular protocol, that type of AV over IP. And that's just a brilliant, easy way to do it. You can still log into the web GUI, right, Laurent? You can still go in the old-fashioned way if you want, but here's a quicker way to do it.
Oh, yes, John. And if you want to get lost rapidly, please do it. And you will see that, all that is configured. So take it simply. The EVUI is a list of certified profiles that are, mutually certified between NETGEAR and these AV over IP manufacturers that partner with us. And this is good because this way you don't have to figure anymore, what you need to do for AVB or what you need to do for Dante or for VLX or AMX or NVX. So with this, you just, tell the switch what to do. And this interface is just sending all these commands to the switch. Then yes, John, you can then control and see it by yourself in the other IT GUI, for instance.
I think a lot of people want to verify what was changed, and it's a good learning experience too. Set the profile up and send it off, and then go back and look and see what's changed, and you can tell what's actually happened in that profile, and you'll be more, you'll have a better idea of what to maybe look for if you have some other issues somewhere else. So that's a good thing. And last thing, AVB. AVB is a topic that's come up a lot in the last several years, certainly for certain specific manufacturers. I know BIAMP uses a lot of AVB, but for us, the licensing has changed and it's much, much easier. So it's one AVB license per switch. And you can find that out. It's on our price list. Wherever you get NETGEAR products from, they'll have it as well. But it's perpetual. One license, one-time fee, you're done for the entire life of that switch. It's for the entire switch, not just per port, and enables you to do a real simple electronic registration for electronic license for AVB. We'll send you the code, you copy and paste it in, and you're done. And that's easy. So thank you for making things easier again, Laurent.
Thank you. And I know that a lot of AVB users question why we need a license. The answer is very simple. AVB is a whole lot of complex protocols from 802.1as to MVRP, MSRP, MRP, all that. And there's a lot of IP, and not all of it is NETGEAR. So that's the truth. Because it's not all our IP, we got to have royalties, and the only way for us to keep it correct for customers that don't need it versus AVB users that will benefit from it is to go through that licenses. But yes, I promise, now it's very plug and play, just copy paste. And second, it's very cost effective.
Well, Laurent, I think we've covered a lot of territory today, a lot of great AV over IP learning, and help people understand a little bit more about NETGEAR's commitment with our engineering services team. And here's a way then to find out some more about what we offer and to recap some of the things we told you about today. Certainly go to netgear.com/ProAV. That's our landing page for ProAV, and you'll find out all kinds of things there. Certainly also use our community website. So community.netgear.com, you'll see a business section and an AV over IP specific forum for questions about AV over IP. I know Laurent's answered questions there that are technical in nature, and I've answered some. We have users answering their own, so that's a good place to go. Laurent mentioned already, we talked about the ProAV design team. So ProAV design at netgear.com, one email address gets you that service. And then here's some specific links to our products we talked about, the 3 different product lines, M4250, M4300, and the M4500. And of course, you'll find us on LinkedIn and Twitter and YouTube. We have lots of other videos for you to watch on YouTube. Thank you for your time today. And if you have any questions, reach out. Laurent, my friend, thank you again. It was a good session. I appreciate all your expertise.
Thank you, John. This is not the end. This is only the beginning. Please come to us.